All right, today everybody we're going to be dealing with translations of sine and cosine functions. We're going to zoom in. Okay. Zooming in to this right here. Okay, so everybody in your journal, you should have y equals a sine bx minus c plus d. Now, I want you to understand this right here just represents your theta. Okay? So in your graphing calculator, that's x just takes place of theta. We have amplitude. We have this thing called phase shift, which is going to be dealing with sliding the graph to the left or to the right. It's going to be translating left to right. And we have a vertical shift right here, which is going to move the graph up or down. So what we're going to do is we're going to look at problem number 1. We're going to go right over here, zoom out. We're going to graph this together. So right now, on problem number 1, what I'd like you guys to write is I want you to write y equals a cosine, open the parentheses, put b theta minus c plus d. Okay? Now, right over here, I'm going to say my a value for this particular graph is a 4. My b value is 1. There is no c value. There's not going to be a phase shift because the c value deals specifically with that. And the d value is 4. What we're going to do is after you write this down, we're going to go and graph this in the graphing calculator. I'm going to put x minimum, x max, x scale, y minimum, y maximum, and y scale. So if we look at our graph right here, our x minimum is going to be at a -2 for our window. We're doing our window settings right now. So on the graphing calculator, this is for your window. But there we go, window settings. We have -2 pi, +2 pi, because it goes from -2 pi all the way to +2 pi. What's our x scale though? What does every single tick mark right here represent? That distance is going to be pi over 2. From here to here is pi over 2. So for x scale, put pi over 2. Y minimum, put a -1. And y maximum, put a +8. For the y scale, put a 1. So we're going to go and do that in your graphing calculator right now. Y minimum is -1. So go to window, type in -2 pi, +2 pi. Calculator automatically changes to a decimal. Your scale, this is technically pi over 2, but I'll just retype it in. Pi divided by 2, saying y minimum, -1, y maximum, 8, and y scale 1. So now I have my window settings. So now I can go to y equals. I can type in a 4. I'm going to type in a cosine. I'm going to type in an x. I'm going to close the parentheses and put +4. Okay? Now make sure your mode's in radian mode. Okay? If you want your grid line on so you can see the grid, it's second zoom. Make sure your grid line right here is turned on. So when you hit graph, you can see your graph. So that's going to be the graph you're going to draw on your paper. Now, there's a new concept called a midline. Okay, this graph has been vertically shifted up 4 units. All right. So I want you to hit y equals. We're going to draw on your midline. If it goes up 4 units, you have a new midline. Your new midline is at y equals 4. So hit graph, and you should see how that graph is split perfectly right down the middle. What do we know our amplitude is from this picture? What do we know from this equation? We know it's a 4, right? Well, if we go back to our graph, you can see clearly that the distance from here, from the midline all the way up, that distance is 4 units. And the distance from the midline going down is also 4 units. All right? So your amplitude is 4. This is our graph. But what line did I say the midline was? I said the midline was y equals 4. Okay? So on your paper, I'm going to go back right here for your paper. Vertical shift. What was the vertical shift? The vertical shift was 4 units. And I said the midline was y equals 4. So on your paper right now, what I'm going to do is I'm going to make a midline right here. On the paper, I'm going to make a midline of y at y equals 4. I'll do that most I can here. It's not really on it. Pretty close. All right. Now, the next thing I'm going to do is I'm going to set some boundaries. I got to go all the way up to what? All the way up to an 8, right? I'm going to make that go all the way across. I realize it's going to kind of cut into your answers, but that's all right. So if we were to go back and look at your graphing calculator, there's your graph. I'm going to label some things. Right here, we're at a negative 2 pi. Way over here is a positive 2 pi. Each one of these tick marks is pi over 2. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So think about where your zeros are. Check this out. Your zeros are right here, right here, right here, pi over 2. This is at negative pi over 2, right here. This is at negative 3 pi over 2, and we're at a positive 3 pi over 2. So go back to your graph. Let's plot those. So where are your zeros located? We at right here at what? Pi over 2. At 3 pi over 2, right here. This is at 3 pi over 2. This is at negative pi over 2. This is at negative 3 pi over 2. So my suggestion, when you're drawing your graph, always plot where your zeros are located on your midline. And that will help you draw a more accurate graph. So plot your zeros. Now we're going to go over here and take a look. Where do I start out at? I start out at way up here at a positive 8, correct? And I drop straight down through. So I'm going to go back right here. I'm going to start at a positive 8. And I'm just going to carefully go through this point. And where does it bottom out? At pi. Or not pi, but negative pi right here, right? So it bottoms out right there, then it jumps back up through this 0. And where does it top out? At a positive 8 again. All the way where? At 0, 8, right? So all the way up. Curves back down. Just looking for a reasonable graph here. Right here at a positive pi, it gets down to 0. It goes back up and finishes where? Right there at 2 pi, correct? Right here at 2 pi, that's where it finishes. So I want you guys just to do the best you can to make a nice, accurate drawing. So why do I want you to use rulers here and here so that you guys have boundaries to be able to draw going up to, all right? Just like a really good painter, not talking about an artist, but somebody who's painting a house. What do they do before they paint? They tape it off, right? I want you guys to think about it that way. You're just kind of setting some boundaries, all right, and so that you know how to go through certain points. What's that? All right, so we call number 2. Just looking at your graph, all right? As we graph this, look at your equation. I'm going to put y equals a sine b theta minus c plus d. What do you think our a value is in this function? What number is right in front of the sine, even though you can't see it? 1. So put a equals 1. What's your b value this time? B value is 2. Your c value is still 0, but your d value is now actually a negative 2. What does the d always let you know has happened? The number at the end lets you know whether it's been translated vertically shifted up or vertically shifted down. went down what? Down negative 2 units. So what's my midline going to be? Y equals what? Negative 2. There we go. So what I want us to do right now is let's look at our, basically, we're still going from what? Negative 2 pi all the way to positive 2 pi. Where am I going to draw my midline in for this one? Negative 2. So make a nice straight line with your ruler right here at a negative 2. That's your midline. Okay. What's my amplitude? 1. So listen, once you have your midline, if your amplitude's 1, literally you only just go up 1 unit, right? With your ruler, draw a nice line going up 1 and go down 1. So technically, we don't need all of the graph to be able to graph this, okay? This sine wave will only be between these boundaries right here. Okay? So I'm going to go right now, and I'm going to change my window. And I'll help you guys out. We're going to go to change the window. We're going to keep the x minimum the same, the x maximum the same. We're just keeping the x scale the same. I'm going to go down to negative 5. I'm going to go up to positive 5. I'm changing my midline. What's my new midline now? Negative 2. Okay, my graph is going to be sine of 2x, close parentheses, minus 2. Just remember, the x just represents theta. Okay? And I'm going to hit graph. Take a look at it. There's my midline. I'm going to plot all of my zeros. So right here, I'm going to plot my zeros. So my zeros are right here. Got a lot of them. It looks like all the zeros happen how far apart? Guess what? Every single tick mark is a 0, right? Every single pi over 2 units is a 0. So let me go back to my graph. Sorry. Right here at negative 2 pi, there should be a what? 0. Right here at negative 3 pi over 2, a 0. So I want you to plot all of those. Plot your zeros first. And that lets you know exactly where your graph's going to go through. After you plot your zeros, notice it goes up and then back down, right? So from right here, start right here, what am I going to do? I'm going to go up and where? Back, down, and back up. Trying to hit right here, right there in between this negative pi and this negative pi over 2 as best as I can. Does everybody understand why I want you guys to use the ruler? Set your boundaries so that you make a nice, accurate graph. This is not perfect. Obviously, it's not as nice and neat as that one right there. But you should be able to use the graphic calculator to help you create boundaries and figure out where you need to plot your zeros in your function. Okay? So basically this video, all it covered, everybody, was basically dealing with your vertical shift and your midline. The next thing we're going to cover is your phase shift in the next video.